Hello, my name is Steve Bowler, and welcome to the Juniper Open Shortest Path First OSPF Lab number 4. In this lab, we're going to take a closer look at how to configure OSPF virtual links on Juniper routers. So first off, let's just take a quick minute to sum up the usage of virtual links, why you would ever want to use them. Obviously, we know that in OSPF, all areas must connect directly to area 0, or all routers. In this lab we have R2, which is the area border router because it is bordering two different areas. We have area 0 between R2 and R1, and then we have area 23 between R2 and R3. Then we have on R3 we have another area, which is area 33, configured on R3's loopback 0.33 interface. And obviously router 3 does not have any interfaces in area 0, so this operation of OSPF, this design, if we do not use virtual links, will not work correctly. The interface, the loopback 33, we will not see being propagated into our area 0, our backbone area. So one way to get around this is if we have a router that does not have any areas directly connected into area 0, we can create what's called a virtual link. And the virtual link is going to be created on R2 and R3. And it's going to transit area 23. So let's go ahead and I'm going to break down our network topology. We'll go ahead and we'll talk a little more about virtual links as we go about configuring this lab. We have R1, we have R2 and R3 in the lab. We have R1 and R2. The link between them is in area 0. And before I get any deeper into our discussion, we're going to see that we are using logical systems in this lab. So if you're using a physical router lab or logical systems, it doesn't matter. You're still going to see the same operation with virtual links. What logical systems allows us to do is to take one physical router and break it up into multiple virtual routers, our logical systems, and then we can connect these virtual routers together using our logical tunnel interfaces. So I have here that all LTs are all logical tunnels equal LT-120.XX. For instance, R1's connection to R2, we are using LT-120.12. And the connection between R2 to R1, R2 is using LT-120.21. So I have two videos on I have two videos on logical systems and how to create connections between them using their logical interfaces, using EM interfaces and LT interfaces. So you might want to go ahead and check those out. Once you go ahead and configure logical systems and the logical interfaces a couple times, it becomes very easy to do, and you can scale your network topology pretty much endless. I think you can support up to 15 or 16 routers on one physical router, so you can get a lot of cool stuff out of them. We're going to do OSPF virtual links in this lab, but you can do BGP, MPLS VPNs, ISIS, and much more. So anyway, sorry about the logical systems overview. I just wanted to tell you that that's what I'm using in this lab. So let's go ahead and start getting this configured on our device. Let's go ahead and create our logical systems. We're going to do set logical systems R1, interfaces LT again 120.12. I'm going to go ahead and just create the connections between the routers. That way we go ahead and build this lab from the ground up. So set logical systems R1, so we have the IP address first. Now we're going to configure our peer unit. It's going to be 21. And the last thing we're going to put on is encapsulation. So if you're not familiar with these commands, the first one, we're just putting the IP address on the logical tunnel interface on R1. We're creating our peer unit. Again, this is the unit that we are peering with on the connection. If we look at our network diagram, we are peering to router 2's .21 logical tunnel interface. So that's why we have 21. And then we have to specify encapsulation. In this lab, we're going to use Ethernet encapsulation. So go ahead on R2, let's create the connection back to R1. We'll do LT120.21 family iNet with the address 12.12.12.2/24. Our peer unit is going to be 12 because that's the logical tunnel interface on R1. And then we're going to use the encapsulation of Ethernet. So I'm going to go ahead and speed through this real quick and just create all of my interfaces. Then I'm going to run back through and explain all of them. This is the connection to router 3. And now we're on R3. We're going to configure our IP address on our logical tunnel. We're going to do our peer unit, which is R2, which is 23. And then the last thing we're going to do is the encapsulation of Ethernet. Actually, one more thing we'll do on R3 is we'll create our interface loopback 0.33 and give it the IP address 33.33.33.33/24. And I believe that's it. Let's go ahead and save the configuration. We'll go back in and I'll just explain this. So we created the connection between R1 and R2. And then we went on R2, we created the connection, we went on to router 2, we created the connection back to R1. Then we also created the connection to R3 using the LT.23 interface. This is in area 23. Also on R3 we went and created the logical tunnel 32 interface. We pointed that back to R2. We also created a loopback 0.33 on R3. So the next thing that I want to do is let's go ahead and do the command set CLI logical system R1. What this command will allow us to do is, before we were sitting at the physical router, now what we're doing with the set CLI logical system R1 is we are actually, it's like we just logged into R1. So now we see R1 at the command prompt as well. So I'm going to go ahead and do that to all of our routers, set CLI logical system R2, and then on this one we'll do set CLI logical system R3. So if I get onto R2, which is right in the middle of our network topology, let's do the command show. We'll just do this. We'll just do a ping 12.12.12.1 rapid count 100. So we're going to try to ping R1 and we can see that we are successful. Now let's try to ping router 3, which is 23.23.23.3 rapid count of 100, and you can see that we're successful there too. So the next thing that we want to do is we're going to enable trace options. Trace options allow us to, they're similar to Cisco debug commands. If you're familiar with those will allow us to catch a lot of the real-time events that are happening within our OSPF network protocol, and we're going to log those events in real time and capture them to a file, and then we're going to do a show log on the file, and I'm just going to show you a couple of things. So we'll go under R2, we'll do the command set protocols OSPF, trace options. We'll just call it file OSPF VL for OSPF Virtual Link Lab. We'll do set protocols OSPF trace options flag, and this is where we're going to tell the trace options what events do we want to catch and send to our file. So we're just going to do all. We're going to trace everything. We'll just do flag all. We'll commit that. So we're going to do that on all three routers. Again, set protocols OSPF. I'm sorry, not logical. Set protocols OSPF trace options. Our trace options file, which we'll just call OSPF VL for virtual link. Then we'll do the command set protocols OSPF trace options flag all. Do the same thing on R1. So for simplicity, we'll just name the file the same on all three routers. And we're going to flag all OSPF events and send it to our file. So the next thing we're going to do is we're going to configure OSPF. We're going to get the basics configured. If we look at our network diagram, between R1 and R2 we are in area 0. Between R2 and R3 those interfaces are in area 23. So that's going to make router 2 the area border router, or ABR. We're going to also set our router ID on R2 and on R3 as well. Last thing we're going to do on R3 is configure area 23 and also area 33. So the router ID in this lab is going to come into practice with our virtual links. We need to set the router ID so that we will see in our virtual link configuration that that portion will come up. So on R1 we'll do the command set protocols OSPF, and if you don't know how to set up OSPF, you might want to go back and take a look at some of my earlier OSPF labs where I show you how to configure the basics of OSPF. We'll do set protocols OSPF area 0, interface LT120.12. On R2 we'll do set protocols OSPF area 0, interface LT120.21. Then we're going to do area 23 on our interface LT120.23. Let's go ahead and commit these changes as I go through. On R3, set protocols OSPF area 23, interface LT120.32, and then area 33 on interface loopback 0.33. So if we have configured everything right, we could go into R2 and let's do that. Let's go into router 2. If I do a show OSPF neighbor, I should see both of my neighbors. It looks like it's in exchange start. So we'll give it another second. Now you can see our state is full. So we have formed a neighbor adjacency with R1. Looks like we're still waiting on R3. It's in exchange start still. Now it's in full. Let's do this. Let's go back under R2. What we forgot to do is I forgot to configure the router ID on R2 and R3. So let's go to router 2. We'll do the command set routing options, router ID, and then if I do a space question mark, it's going to ask us for the router identifier. In this case on R2, we'll just do 2.2.2.2. We'll commit that. We'll do the same thing on R3. We'll go under set, routing options, and then if we do a space question mark, you can see we have a lot of stuff we can configure under routing options, but we're going to be concerned with the router ID portion, because this is what we are going to use in the OSPF virtual link implementation. So we'll do set routing options, router ID. On R3 it's going to be 3.3.3.3. We'll commit that and exit. And now on R2, if I do a show OSPF neighbor, we can see that we have adjacencies with R1 and R3. We can see the ID for R3 is 3.3.3.3 now. If I go under R1 and do a show route, we can see that we have one route learned via OSPF, and that is the 23 network. If we look at our network diagram, that's the network between router 2 and router 3. So that's good that we have reachability to that. On R1, if I go ahead and try to ping router 3, which is 23.23.23.3, we'll do a rapid count of 1000. You can see that we have reachability. However, if we do a show route, you can see that we don't have the 33 network showing up in our routing table on R1. Let's go to R2. If I do a show route on R2, you can see that I don't have it in router 2's routing table either. So on R3, if we do a show configuration, we can see and verify under the OSPF we have configured interface loopback 0.33 under area 33, but for some reason it's not populating to R1, and we have defined loopback 0 unit 33 as well. So the reason why the 33 network is not being propagated to router 2, or for that matter into area 0 at all, is because router 3 does not have any interfaces in area 0. And we all know that within OSPF all routers must connect to area 0 if they have multiple areas attached to them. So in this case, router 3 is trying to say that it has area 33 and area 23 attached to it, but that operation will not work. Router 2 does work, and it does advertise the 23 network in area 23 to the backbone, which is area 0. And that's because it has an interface in area 0. So what we need to do on R3 is we need to create what's called a virtual link and bridge R3 to area 0 in order for the 33 network to show up in the backbone in area 0 and reachable through R1. Because right now if we do a show route, obviously we don't see the 33 network in the routing table. Okay, so let's go ahead and configure the virtual link. Under R2, we go under Edit Protocols OSPF. To configure the virtual link, we're going to do the command set follow it up with area, and we're going to use area 0 for the virtual link. We're going to do set area 0, and we can see that we have the option, the last option, which is virtual link. If I try to do area 23, if I do set area 23 space question mark, you can see that we don't have the option for the virtual link because it is explicitly done in area 0. So we'll do the command set area 0 virtual link. If I do a space question mark, you see we have two possible completions. We have the neighbor ID and the transit area. So what I'm going to first do is do the transit area. So in this lab, we're going to be transiting area 23 on both R2 and R3. Let's go back to R2. We'll do the command set area 0 virtual link transit area. Follow that with 23. And if I do a space question mark, we can now see that we have the option for the neighbor ID that we need to fill in. And this is the router ID of the neighbor. And in this case, for router 2, we are appearing the virtual link across to router 3, and router 3's router ID be set to 3.3.3.3. So let's go back to R2. We'll do the command, we'll just put in 3.3.3.3, and that should be it. So we'll go ahead and hit enter, and we'll commit that. And now we're going to go under router 3 and we'll do the same thing. Let's go under edit protocols OSPF. We're going to do the command set area, and then we're going to do, if I do 23, you can see that nothing comes up. I don't have the option for the virtual link. So that's why we're going to do set area 0 space question mark, and then you can see we have the option for the virtual link. So it's very important that you understand that configuration. Set area 0 virtual link. We're going to first do the transit area. In this case, the transit area is 23. And then we're going to follow it up with our last option, which is our neighbor ID. In this case, from router 3's perspective, our neighbor is router 2, and we have configured the router ID on R2 to be 2.2.2.2. Let's go back to router 3 and set that as our neighbor ID. We'll go ahead and commit this. And let's go ahead and make use of our trace option. Let's go to router 2. If I do a show OSPF neighbor detail, and now we can see that the virtual link is up. Let's do this without the detail first. Before, what we saw is when we did the show OSPF neighbor on R2, before we configured the virtual link, we saw that we had a neighbor with R1 and R3 neighbor relationship on the logical tunnel interfaces. And now if we do a show OSPF neighbor on R2, we can see that we have another neighbor relationship with R3 across the VL interface. So this is the virtual link interface. On R2, if I do a show log OSPF VL, let's go ahead and see if we can find any events. I'm pretty sure we should be able to find the virtual link. Let's go ahead and do this. We'll do a show log. We'll match on virtual. And we can see that we have some options, or I'm sorry, some events in here showing the creation of our virtual link. So we have finished processing for link type virtual link ID, and we have the connection. If I do a show route on R2, we can now see the 3 network added into the routing table. If I do a show log, let's match the 33 network. We can see that as soon as the virtual link came up, we can see that the 33 network was added into our routing table. So that happened at 051108. If we do a match on the virtual, that is the exact time where our virtual link, it appears, is that our virtual link was added. You can see the added link type virtual link. So everything looks good on R2. We can see the virtual link connection. Let's go to R3. If I do a show OSPF neighbor, we can also see that we have a virtual link connection to R2 as well. So everything seems to be fitting in just fine. If I do a show route on R1, we can now see that the 33 network has been added to the routing table on R1. If I do a show log OSPF VL, we can see again at 051108 the 33 network being added to our routing table. So one of the last steps, excuse me, sorry about that. One of the last steps that we want to do is we now see that we have the network in our routing table. We have the 33 network. Let's go ahead and do a ping. See if we can ping the 33 network. And you can see that we have reachability and that we are successful. So that wraps it up. That's Juniper Open Shortest Path First, OSPF lab number 4. In this lab we looked at how to configure and verify the operation of virtual links. Excuse me. On R2 and R3 is where the configuration of the virtual link occurred. Let's go back and just show you one of the, on R2 if we do a show configuration, we saw that the virtual link was created under area 0. We had the neighbor ID that we had to specify. Again, this is the router ID for R3. And the transit area, this is the area in which the virtual link rides over. And this was area 23. Same thing on R3 if we do a show configuration. We have the virtual link under area 0. Our neighbor ID, which is the router ID of R2, and the transit area, which is the same as on R2, which was area 23. So this is, you can think of the area in which the virtual link endpoints have in common, which is area 23. Once we configured our virtual link, we saw that the 33 network was then propagated to R2, and R2 propagated it to the backbone. And we saw on R1 it came up in the routing table. We were able to ping all the way to the 33 network. We also did some show commands with our trace options. We did some show logs and some show OSPF neighbor to see the addition of the virtual link. So thanks for watching, and I hope to see you in the next video.